Hello everyone, I'm Swarat. Today we are discussing about class 11 physics chapter number 5. In this lecture we'll discussing about the solving problem in the mechanics. So the three laws of motions that you learn in this chapter are in the foundation of the mechanics. You should know be able to handle a large variety of a problem in mechanics. A typical problem in a mechanics usually does not merely involve a single body under actions of given force. More often, we will need to consider an assembly or different bodies and exerting the force on each other besides each body in the assembly experience the force of gravity. So when trying to solve a problem of this chapter of this type, it is useful to the remember in the fact that we can choose any part of the assembly and apply the law of motions to that the provide we include all force on the chosen part due to the remaining parts of the assembly. We may call the chosen part of the assembly as the system and the remaining part of the assembly as the environment. So we have so all follow the same method in solve the example. To handle a typical problem in a mechanics systematically, one should use the following step: draw the diagram showing the schematic and the various parts of the assembly of the body, the links and supports, etc. Choose a convenient part of the assembly as on one of the system. Draw the separate diagram which shows this system and all force on the system by the remaining part of the assembly. Include also the force on the system by other agencies. Do not include the force on the environment by the system. A diagram of this type of is known as the free body diagram. Not this does not imply that the system under the considerations is without need of innate force. In a free body diagram, include the informations about force, their magnitude, and the directions that are either given or you are sure of the directions of tension in a string along its length. The rest should be tested as unknown to be determined using the law of motions. And also the last point is that if necessary, follow the same procedure for the another choice of the system. In the doing so, employs Newton's third law. That is if in the free body diagram of A, the force on A due to the B is shown as F, then the free body diagram of B, the force on B due to the A should be minus F. So the following example illustrate about the procedure. Now see here, the another topic is that solving the problem. Sorry, action and reactions pair. Okay, so a force on gravity on the 20 newtons on the block by the earth, the force on gravity on the earth by the block reactions equal to 20 newton direct upward. No, not shown in the figure. So see here the force of the body of the floor by the block actions, the force on the block by the floor reactions. Now see here the B is that the force of gravity is 270 Newton on the system by Earth say actions, and the force of gravity on the Earth by the system reactions equals to the 270 Newtons. So the direct upward not shown in the figure, the force on the floor by the system actions, the force on the system by the floor in the additions for the force of the block by the cylinder and the force of the cylinder by the block. Also the consider the actions and reactions. So the important things to remember is that actions reaction pair consist of mutual force which are always equal and opposite between two bodies. So two force on the same body which happen to be equal and opposite, so can never constitute an actions and reactions. So the force of gravity on the mass in A or B, the normal force on the mass by the floor are not actions and reactions pair. So therefore this force happen to be equal and opposite force since the mass at the race they are not so far for case. So see here, the important of things is remember is that the actions reactions pair consist of the mutual force which are always equal and opposite between two bodies. Two force on the same body which happen to be equal and opposite can never constitute an actions reactions pair. So the force of gravity on the mass A on B and the normal force on the mass by the floor are not action pairs. So this force happen to be equal and opposite force since the mass is at rest. They are not so far for case B. As seen already, the weight of the system is 270 Newton, while the normal force R dash is the 267.3 Newton. So the practice of drawing free body diagram is of great help in the solving the problem in mechanics. It always allows you to clearly define your system and consider all force on the system due to the object that are not part of the system itself. The number of experience in this and the subsequent chapter will help you creative this practice. So see here, now see we have I show you the summary of this chapter. What is the first one is that we are discussing about the Galileo. Everybody continues to move in the state of the rest uniform motion in a straight line unless they compelled by the some external force to act otherwise. So it is a simple terms. The first law is and the is external force on a body is zero, the acceleration is zero. Second thing we already derived is that the momentum of body is product of the mass p and the velocity v. And the Newton's second law of motions is that the rate of change of motions of body is proportional to the applied force and taken place is in the directions in which the force act. So thus the F is equals to k dp by dt, where k is equals to 1, so k is equals to m into a. So where the F is the external force on the body and the A its acceleration, where we set the constant of proportionality k is equals to 1 in such in SI unit is that, so the F it is equals to dp by dt is equals to ma. And after we are discussing about that the SI unit of the force, okay, is Newton. 1 Newton is equals to 1 kilogram meter per second. The second law is consistent with the first law. F it is equals to 0 implies it is equals to 0. Second thing is that it is a vector equations. It is applicable to the particle and also to a body or a system of a particle. Provide F is the total external force on the system and A is the acceleration of the system as a whole. And also the at f at a point at a certain instant determined at the same point at that instant, that is the second law is local law. A it is and instant does not depends on the history of the motions. So impulse is the product of force and the time which equals change in momentum. So the motions of impulse is useful when the large force act for a short time to produce a measurable change in a momentum. Since the time of actions of the force is very short, one can assume that there is a no appreciable change in the positions of body during the actions of the impulsive force. And the Newton's last law is that the Newton's third law of motions, to every day every actions there is a equal and always equal and opposite reactions are there. So these are that in simple terms the law can be stated thus: the force is nature always occur between the pair of bodies. Force on a body is by body b is equals and opposite to the force on the body by b by a. So the action and reactions are simultaneous force. This is no force, this is no cause effect relation between action and reactions. Any of the two mutual force can be called the action and other reactions. The action and reaction act on a different bodies and so they cannot be cancelled out. So the internal actions and reactions force between the different part of body are sum of to zero. And then after we are discussing about that the law of conservation of momentum. Total momentum isolated system of particle is conserved. The law follows from the second and third law of motions. Then after we are discussing about the frictions is that the frictional force oppose relative motions between two surfaces in the contact. It is the important of the contact force along the common tangent to the surface in contact. The static friction F of S oppose the impeding the relative motions. Kinetic frictions F of K oppose the actual relative motions. They are independent of the area of contact and satisfy the following approximate laws. So Fs is less or equals to Fs maximum, it is equals to mu s into R, and f of k it is equals to mu k into R. So mu s and mu k coefficient or kinetic frictions are the constant characteristic of pair of the surface in contact. So it is found experimentally that the q mu k is less than the mu s. So see, this is our that. Now see the symbol of that. What is that? Okay. So thank you guys, thank you so much. Okay, now we will discussing about next, like next chapters. So thank you guys, thank you so much.